Hi guys! Magandang araw po sa inyong lahat. This is me, Sean from Keep It Up with Sean, and today we are on the 7th video of this lecture series, and we are going to talk about physical properties of the soil, particularly particle density, bulk density, and soil porosity. Pero bago tayo mag-discuss niyan, kumusta nga pala yung result ng mock exam nyo? So I hope nakatulong sa inyo yung mga questions na na-prepare ko, and I found those questions online. So, sana you have time to practice and answer to test your knowledge about soils. So, for this video, meron akong bonus sa inyo. So, at the end of this presentation, I prepared 68 questions para matest rin yung knowledge nyo about this topic. So, huwag kayong mag-alala. It's not yet an exam. So, the most important thing is that you understand the basic concept and you understand why your answers are correct. So, if you are new to my channel, please click the subscribe button and it will help me a lot. And kung meron kayong mga questions, please let me know so that I can help you and answer you kung ano yung makakaya ko. So, thank you again and see you again in my next presentation as we talk about soil water consistency, aeration, and temperature. So, see you later, guys! Welcome again to the 7th video. And for today, we are going to talk about the physical properties of soil, particularly soil density and porosity. Soil density is divided into two kinds. So, meron tayong particle density and we also have bulk density. So, soil weight is most often expressed on a soil volume basis rather than on a particle basis. So, ano yung pagkakaiba ng particle density at saka bulk density? The particle density is the mass of the soil particles divided by the volume of the soil solid particles alone. While the bulk density, it is the ratio of the mass of a dry soil to the total volume of the soil. So, ito yung pagkakaiba nila. Density considers both the solids and the pore space, while particle density considers only the mineral solids. Yung solids niya lang yung kinoconsider in particle density. Samantalang sa bulk density, kasama niya ngayon yung solid part at saka yung pore space part. So we have here in the left side, we have the particle density which considers only the solid fraction alone. Samantalang sa bulk density, consider niya ngayon yung pore spaces at saka yung solid parts. So in the bulk density, we have there 50% solid and 50% pore space. So kung ang total weight ng soil natin ay 2.66 gram, the bulk density, we can have around 1.33 gram kasi kasama niya ngayon yung pore space. So, the particle density is normally calculated as 2.65 gram per cubic centimeter for most mineral soil particles and 1.3 gram cubic centimeter for organic matter. So, the bulk density is an indicator of low porosity and soil compaction. This is the ratio of the mass of dry soil to the total volume of the soil. So, total volume of the soil, kasama niya ngayon yung solid spaces at saka yung pore spaces. It is determined by dividing the weight of often dry soil in grams by its volume in cubic centimeters. And the variation in bulk density is due largely to the difference in total pore space. And the bulk density of common surface soil is 1.1 to 1.4 gram per cubic centimeter. Samantalang, as you go deeper, it will be around 1.3 to 1.7 gram per cubic centimeter. So, the more na nagdidig ka pa ilalim, the more na tumataas yung kanyang bulk density. Kasi, kasama na din dun yung weight na nakaipatong sa kanya. So, as you go deeper, your bulk density is going to get higher. So, ano ngayon yung significance ng bulk density? Bulk density is usually considered in engineering properties, especially pag magpapatayo ka ng mga bahay, ng mga roads. And it is also necessary for the determination of the water movement at saka yung rooting depth ng plants. Kasi pag medyo mataas yung bulk density mo, penetration ng roots at saka yung haba ng roots will also be affected kasi kung masyadong mataas yung bulk density mo, nagiging compact na yung lupa. So we know that the bulk density is the oven dry weight divided by the total volume of the soil. So paano ba dinedetermine yung bulk density? So we have here the ring cylinder method. So this method works best for most moist soils without gravel. So paano nila ginagawa? So this is done by prepare an undisturbed flat horizontal surface in the soil with a spade at the depth of you wish to sample. And then push or gently hammer the steel ring into the soil. And a block of wood may be used to protect the ring. So avoid pushing the ring in too far for the soil will compact. So wag mong idiin masyado kasi magiging compact na yung lupa. And then you excavate around the ring without disturbing or loosening the soil it contains and carefully remove it with the soil intact. Remove any excess soil from the outside of the ring and cut any plants or roots off at the soil surface with scissors. And then you pour the soil into the plastic bag and seal the bag, marking the date and location where the sample was taken. And isa sa mga common source ng error when measuring bulk density are na di-disrupt yung soil while sampling. So, ang nangyayari, nagkakaroon ng inaccurate trimming and inaccurate measuring of the volume of the ring. So, gravel, kung may mga bato, can make trimming the core difficult and give inaccurate values. So, it is best to take more samples to decrease error in this way. So, ngayon, paano natin siya i-calculate? So, yan siya. So, i-hammer mo yung ring cylinder mo sa ilalim ng lupa. Pero wag mong masyadong pukpukin para hindi mag-compact yung lupa na measure mo. So, you determine first the soil volume. So, how do you determine the soil volume is you determine the ring volume. Kung yung cylinder net. So, to calculate the volume of the ring, we measure the height of the ring with a ruler. And then you also measure the diameter of the ring and half this value to get the radius. So the ring volume will be 3.14, which is the pi r squared, times the height. So if the ring diameter is 7 cm and ring height is 10 cm, the ring volume would be 3.14 times 3.5 r squared times 10, which is around 384.65 centimeter. Cubic centimeter. So, ngayon, yung lupa na nakuha nyo, you weigh an oven-proof container in grams, so empty, wala pa siyang laman, and then you carefully remove all soil from the bag into the container. You dry the soil for 10 minutes in the microwave or for 2 hours in a conventional oven at 105 degrees Celsius. You let it cool down, and when the soil is dry, you weigh the sample on the scale. So, since meron na tayong weight in the first time, which is the empty, and then we also have the weigh when it's oven dry weight, so pwede na natin makalculate ngayon yung soil weight. So, we just calculate the second weight minus the first weight. So, meron tayong 425 gram na soil. Assuming na ganito yung value ng weight natin, ha? So, we have this. So, to calculate the bulk density, so we know that it's the oven dry weight over the total volume of the soil. So, we have there. So, for this kind of soil, based sa example natin, our bulk density is 1.1 gram per cubic centimeter. Yun. So, this is just an example. Okay, so I hope you follow this, guys. I'm going to show you more calculations later on para ma-practice natin siya. But then, I just want you to know the concept how to calculate the bulk density. So, bulk density is oven dry weight over the total volume of the soil. And then we also have another kind of method to determine the bulk density, which is the use of penetrometer. It is easy and reliable method for determining in-place soil strength and great for checking building pods, excavations, or potential building sites. And it just simply measure the penetration and look up soil strength on the strength card included with the unit. So, itutusok niya lang dyan yung penetrometer sa ilalim ng lupa, and then it will give you an information how strong is your soil. So this is the table showing you the relationship of the soil bulk density to root growth based on soil texture. Kasi iba-ibang texture ng lupa is meron din siyang iba't ibang bulk density. So for sandy soil, the ideal bulk densities for plant growth is less than 1.6 gram per cubic centimeter. For silty is less than 1.4, and for clay is less than 1.1 gram per cubic centimeter. And ito naman yung mga bulk densities that restrict root growth. So, ibig sabihin, if you have a sandy soil and your bulk density is higher than 1.8, meaning mataas yung bulk density mo, there will be a problem with your roots, your plants, kasi medyo mahihirapan yung roots mo to penetrate the soil kasi matigas siya. So, sandy is more than 1.8, silty is for more than 1.65, and clay is more than 1.47. So, the higher the bulk density, it will give you an idea that your soil is highly compacted. The higher the bulk density, the greater is your soil compaction. So bulk density is affected by organic matter content, mineralogical composition of your soil, the porosity of the soil depth, and the soil texture. It is dependent on soil texture and the densities of the soil mineral kasi iba-iba yung bulk density ng sand, silt, and clay, as well as ng organic matter particles, at saka kasama na rin yung kanyang packing arrangement. So as a rule of thumb, most rocks have a bulk density of 2.65 gram per cubic centimeter. So ideally, a medium textured soil with about 50% pore space will have a bulk density of 1.33 gram per cubic centimeter. So yung particle density, guys, mostly standard siya. Usually yung sa mga calculations natin, ginagamit natin dyan is 2.65 gram per cubic centimeter. So generally, loose, porous soils and those rich in organic matter have lower bulk density. So pag mababa yung bulk density natin, less din yung compaction ng soil. So less compaction, meaning hindi mahihirapan ang roots ng mga tanim nyo to penetrate in the soil. Sandy soils have relatively high bulk density since the total pore space in sands is less than that of silt or clay soils. So, mas mataas yung bulk density ng sandy soils. So, mas prone siya ngayon sa compaction ang sandy soils compared ngayon sa clay or silty soils. Finer textured soils such as silt and clay loams that have good structure have higher pore space and lower bulk density compared to sandy soils. And bulk density typically increases also with soil depth because the subsurface layers have reduced organic matter, aggregation, and root penetration compared to surface layers and therefore contains less pore space. Also, the subsurface layers are also subject to the compacting weight of the soil above them. So, syempre, naiipit din siya doon. So, it adds yung weight ng ibabaw na lupa, nag-a-add din siya ng weight dun sa subsoil. Kaya nagiging mas lower, mas compacted na yung subsoil mo. And bulk density affects water and air transport in soils, kaya it's very important property ng lupa. And soils with high densities resist water and air transport. And soils with high density may also impede root growth kasi hindi siya nakakapag-penetrate. And a lot of human activities also affect bulk density. So tayo din mismo as mga tao, we also causes the compaction of the soil. through our own different activities. Soils at construction sites are generally compacted as a result of excavation, mixing, stockpiling, or equipment storage and equipment traffic. So when soil is compacted, the porosity increases and bulk density increases. As a result, the permeability of air and water in the soil decreases. So, hindi masyadong nakakapag-penetrate at yung air at saka water. And the soil water holding capacity is reduced and root growth is impeded. And when the soil in an area is compacted, it will also lead to increased runoff and erosion. So, marami siyang effect, guys, pag compacted yung lupa. Then we also have soil porosity. The porosity of or pore space refers to the volume of soil voids that can be filled by water and or air. It is inversely related to bulk density. So meaning, kung mataas yung inyong pore spaces or percent of porosity, mababa naman ngayon yung bulk density mo. Meaning, less yung compaction mo pag mataas yung porosity. So porosity is calculated as a percentage of the soil volume, the volume of the pores divided by the bulk soil volume. So yan. So pore space is very important for providing aeration and paths for water to flow and be stored. So in this picture, we have here, sa taas, meron tayong mga clay aggregates, and lower side is we have coarse sand grains. So, tingnan nyo yung mga clay aggregates. So, meron siyang ganyan. Tapos, in between doon, meron pa siyang mga maliliit na mga pores. So, we have there micropores and also macro pores. So, ibig sabihin pag macro, medyo malalaki, di ba? And micro is maliliit. So, macro pores, these are pores larger than 0.08 millimeter. And it allows the movement of air, water, and plant roots. So, dito penetrate, dito dumadaan yung air, water, at saka plant roots. Samantalang ang micropores, these are pores smaller than 0.08 millimeter, and it is usually water-filled in field condition. So, the pore size, which is next to soil structure, is probably one of the most important physical properties of a soil because it controls water and air movement, kasama na rin doon yung storage. It can be big or small, although clays have predominant. Ano sa tingin nyo ang may mataas na porosity? Sandy soils or clay soils? So before natin yan sasagutan, we are going to compare this pore space in sandy soil versus clay soil. So, saglit ha. Yan. So, imagine a glass baso. So, punuin niyo siya ngayon ng sandy soil. Yun, sa left side. And then, yung isa namang baso is punuin niyo siya ngayon ng clay soil. So, kung pupunuin natin yan ng yung baso na yan, siguro nakailang dampot ka lang ng sandy soils, ilang dampot mo lang, tapos ilalagay mo siya sa baso, napuno mo siya kaagad. Samantalang sa clay soils, makakailang dampot ka niyan kasi matagal mo siyang mapuno yung baso na yan. It's because the sandy soils have larger pores kasi medyo malalaki yung kanyang mga texture. While yung clay soils is marami siyang mga smaller pores. So, ang mangyayari dyan sa sandy soils, there will be less total pore volume, meaning, nagiging less yun yung kanyang porosity. Samantalang sa clay soil, since medyo malilit yung kanyang mga pores, there will be greater total volume, pore volume, kasi kahit maliliit yung kanyang mga pores, marami ka namang mga clay materials na nilalagay doon, and each of them have small pores, kaya kung itotal mo yung lahat ng mga pores na nandun sa clay particles, it will create ngayon the greater total pore volume. So, meaning, mas mataas yung porosity ng clay soils compared to sandy soils. So, nasabi ko nga, a large number of small particles in a volume of soil produces a large number of soil pores, and fewer large particles can occupy the same volume of the soil, so there are fewer pores and less porosity. Kaya, mas mataas yung porosity ng clay soil compared to sandy soils. So, loose porous soils have lower bulk densities and greater porosities than tightly packed soils. And it also varies depending on the particle size and aggregation, and porosity is greater in clayey and organic soils than in sandy soils. So, paano natin kinakalculate yung porosity? So, this is the portion of soil occupied by water and air. So, both water at saka air. So, the porosity, which is usually E, is calculated by 1 minus the bulk density divided by the particle density times 100. So, kung meron ka ngayong 1.6 gram per cubic centimeter na bulk density, you divide it by 2.67 or 2.65 gram per cubic centimeter times 100. So, you will have now a porosity of 40.07%. And porosity influences air and water movement in the soil. And we also have a bearing capacity, which is determined by soil texture. So this is the ability of the soil to withstand a load or the average load per unit area that will cause failure by rupture of a supporting soil mass. Kaya, in engineering purposes, they usually calculate the strength of the soil at kung ano yung strength ng material na ilalagay mo dun sa soil. Kasi, you cannot just build ilang stories ng building kung yung lupa mo naman is hindi niya kaya ngayong i-sustain yung weight ng building na ipapatayo mo. So, they also do stabilization. Soil stabilization is a method that prevents a soil system from moving under a load. And the compaction is also very important because it increases the density, thereby increasing stability, and is usually apply large pressure to soil at optimum moisture. And we also have the shrink swell potential. We abbreviated it as S because some of the may mga iba't ibang lupa, particularly some kinds of clay, has the high potential of shrinking and swelling. So, yung iba dyan nagka-crack. So, kaya it's very necessary to identify which kinds, anong klase ng lupa ang meron ka, especially kung you are going to build a lot of high-story buildings dun sa lupa na yon. So, soils with more than 30% clay have a high shrink-swell capacity. Ibig sabihin, pag mataas yung clay content mo, mas mataas din yung shrink-swell potential, lalo na pag yung mga clay mo is 2:1 expanding type. And to avoid this problem, soil must be compacted and water must be kept out. And without the above, shrink swell will crack foundations and pavement or move telephone poles. Kaya yung iba, kung kita mo, yung iba mga poste ng power light, electricity light, yung iba nagbe-bend na siya, di ba? Kasi, syempre, yung lupa mo naman, hindi siya stable always, di ba? So, may mga tendency na nag-sway siya dun sa kabilang side or sa other side. So, this is a pole leaning due to the shrink swell of the soil. So, iba din na effect niya is yung ganito. So, yung nangyayari yung mga pader ng mga bahay natin, after a time, nagka-crack siya gawa nga nung movement ng lupa natin. So, isa din yan sa cause while kailangan natin i-compact yung lupa natin before tayo magpapagawa ng bahay. So, the leak of foundation due to unstable soil due to high shrink swell potential. So, ang ginagawa niyan is, in construction, kaya gumagamit sila ng pison, di ba? Para ma-compact yung lupa para maging stable ngayon. Kung meron ka dyang ipapatayo na bahay or foundation or roads and buildings. So, kailangan talagang compact siya para hindi siya gagalaw later. So, soil stabilization is a process by which a soil's physical property are transformed to provide long-term permanent strength gains. It is accomplished by increasing the shear strength and the overall bearing capacity of the soil. And how to do this? They apply lime, cement, Portland, and pozzolan with high silica volcanic ash as chemical additives. And the lime is the most effective on clay soils and can be used in combination with cement and pozzolan. So this is what happened to the Leaning Tower of Pisa in Italy. So here they were constructing white marble bell tower for the cathedral complex in Pisa in Italy. And this is just, I don't know if it's correct, kaya yung cartoon na yan. They were thinking of saving 700 lira by not taking soil test. But then, this is true, by the time builders had finished the third of the 8 planned stories, about 5 years later, the tower's foundation had begun to settle unevenly on the ground beneath it, which is a dense mixture of clay, sands, and shell. And as a result, the structure had begun to tilt visibly towards the south. So they did a lot of efforts to strengthen para maging stable yung structure na yan. But then after ilang years, hindi pa rin siya na-solve. And then so we just have now the Leaning Tower of Pisa in Italy. So these are some example calculations to review kung paano tayo magka-calculate ng mga bulk density at saka porosity. So here, question number 1, what is the bulk density of a 765 gram dry soil sample that has an undistributed volume of 510 cubic centimeter? So we know that the bulk density is calculated as the oven dry weight over the total volume of the soil. So in this case, i-divide mo lang ngayon yung 765 gram ng dry soil divided by 510 cubic centimeter. So here, our bulk density is 1.5 gram per cubic centimeter. Second problem is, what is the porosity of the soil in question number 1, assuming that the particle density is 2.65 gram per cubic centimeter? So the porosity is equal to 1 minus the bulk density divided the particle density times 100. So it would be 1 minus 1.5 divided by 2.65 times 100. So the pore space will be 43%. Then we also have another third problem. Research has shown that corn roots are unable to penetrate a layer of soil having a bulk density of 1.85 gram per cubic centimeter. So what is the porosity in a soil this dense? So yun. So here, same lang din. So you divide the bulk density of 1.85 divided by 2.65. So we have here 30% porosity. And then question number 4 is, compaction by tillage implements change the bulk density from 1.2 to 1.7 gram per cubic centimeter in a portion of the root zone. So, ibig sabihin, from 1.2 naging 1.7 siya. Ibig sabihin, nagiging compacted yung lupa mo kasi tumataas yung kanyang bulk density. The questions are, what was the initial porosity? Second question is, what is the compacted porosity? And number 3 is, what percent of the soil's porosity was lost due to compaction? So to solve the first question, so initial porosity would be 1 minus 1.2 divided 2.65 times 100%. The initial porosity is 55%. And the compacted porosity is 1 minus 1.7 divided 2.65 times 100 is 36 porosity. So ibig sabihin na yung initial niya is 55% yung porosity. But then, when the soil gets compacted, yung tumataas yung kanyang bulk density, bumababa naman ngayon yung kanyang porosity. So from 55, nagiging 36%. And then what is the porosity loss? So we have just here, 55 minus 36 divided by the initial porosity times 100. So we have here, the porosity loss is 35%. And the last but not the least problem. So we have here, during construction of new golf greens, workers use an 8.8 is to 2 sand to peat mix. So if they're mixed, yung sand to peat mix, so meron siyang organic matter. So if their mix has a mean bulk density ranging from 1.17 to 1.42 gram per cubic centimeter, what is the porosity of a golf green made from this material? So kunin muna natin yung average bulk density. So we have here 1.17 to 1.42 divided by 2. So we have an average bulk density of 1.3 gram per cubic centimeter. And then we calculated the porosity by using the formula. And we have the porosity there of 51% porosity. So thank you and see you again in my next presentation. I hope you learned something from this video. And then since dumating kayo dito sa side na to, I have a bonus for you, which is a mock examination to test your knowledge. So this is composed of, I think, around 67 questions, just to test how you understand the concept of soil bulk density, particle density, and the porosity. So I hope you are ready. You get your pen and paper now, and we will try to answer the questions. It doesn't matter if your scores are low. The important thing is that you understand the concept and you know why your answers are correct and why your answers are not correct. Okay? So I hope you are ready now. So let's begin the first question, and then the following slide will give you the correct answer. So 68 questions pala siya. And after this mock exam, the next presentation that I'm going to give you is also a physical properties of soils. And this will be the last topic in the physical properties of soil. And we're going to talk about soil water, consistency, and aeration and temperature. So I hope ready na yung mga papel at yung mga pen nyo. So the first question will be, So, ano yung mga scores niyo guys? So, I hope you understand the concept and the reason behind the answer, and you can always practice if you have time. So, thank you again and see you in my next presentation. And the next topic will be about soil moisture, soil consistency, soil erosion, aeration, and soil temperature. So maraming salamat guys, and if you are new to my channel, please click the subscribe button and it will help me a lot. Thank you. Bye.